This is an interesting question on arrangements. We're trying to create an 8-digit number using only the digits 1, 2, and 3, so the difference between any two adjacent digits is 1. So let's just start off with an example. Let's say it starts with a 2, then we can either pick 1 or 3. Maybe I pick 1. Now I don't have a choice on my third pick, I have to pick 2. Maybe I'd then pick 3, then I have to pick 2 again. And then maybe I go with 3 again, I have to pick 2 there, and maybe I end with a 1. So you can see if I pick the first one as 2, then the third, fifth, and seventh have to be 2 as well to satisfy this little requirement. And that means I could have a number, all my 8-digit numbers that start with a 2 would look a bit like this, where the little lines mean I could pick 1 or 3. Now, I could alternatively start with 1 or 3, and then it's going to have to again alternate. And those are the only possible numbers that I can make. So the question is, how many different arrangements can I get within this? There's going to be two choices for each, where each of these arrows are. And what we end up doing is multiplying those like 2 times 2 times 2 times 2. It's actually going to become 2 to the 4 choices. It's a little bit like if we had 6 starters and 7 mains, then for every single starter, you could have 7 mains. So 7 plus 7 plus 7, like 6 times. And so it's 6 times 7. Now let's say you then bring in, say, 3 desserts. For every dessert, you're going to have 6 times 7 possible starters and mains. So it's going to be 3 times 6 times 7. And this is the idea behind the product rule of counting. And it's what we're doing here. We've got, for all your choices, we can use the same choice. So it's 2 times 2 times 2 times 2. So I hope that makes sense. It's going to be exactly the same for this second configuration where we started with 1 and 3. So overall, the answer is going to be 2 lots of 2 to the power 4. That's separating like that. I think it makes sense. 2 to the 4 is 16, times by 2 again gives 32.